Hello students, my name is Ashwini and welcome to my YouTube channel. In this video, we will be discussing about the PCY algorithm, which is a big data algorithm. So, the PCY algorithm, which stands for Park-Chen-Yu algorithm, is used to find out the frequent item sets from a large data set. Let me tell you, in this video, we will be trying to solve a sum. For theory, we will be making another video. So how the question will be asked to you, that a frequent item set will be given, okay, and they will be saying using a PCY algorithm, find out which are the candidate sets which satisfies the threshold value. So in this example, the threshold value is given as 2. Let me tell you, this algorithm is named behind the 3 scientists who have worked for this algorithm, that is Park, Chen and Yu. So for the first step, you will try to find out what is the count of every item. Now let me tell you, even though there are 6 transactions, there are, if you can see, only 5 items which has been brought in random. So we have to find out how many times each item has been brought. So here we will try to make a table which is called as item and the count. So let me say my item 1 has been brought 1, 2 and 3 times. Like that, my item 2 is being brought 1, 2 and 3. So I will make the table. My item 3 is brought 1 and 2, so only 2 times. Okay, like that, my item 4, if you see, 1, 2, 3, 4 and 5, and item 5 has been brought 4 times. Now let me tell you, sometimes instead of giving numbers, they may also give you a nominal attributes like bread, butter, jam, They may also give you sometimes alphabets like A, B, C, D. Those are nothing but only representing the items brought in a transaction. In any case, you have to solve it in the same way. First, find out the count of every item. Now we have to find out of these items, which item has satisfied our threshold. As we know, the threshold over here is 2. So we'll try to find out, is there any item which has been brought below 2. As none of the items has been brought less than 2 times, all the items satisfies the condition. So the candidate list for a step 1 consists of all the items, that is 1, 2, 3, 4 and 5. Okay, that is what we have written over here. As individual items have satisfied, we will go to the second level, that is called as finding the key value pair. We will write down the transactions, we will write down the items and we will try to find the pair. Now which pair has been brought together? So here, as we know, the transaction 1 had 3 items, 1, 3 and 2. They could be brought in pair of either 1, 2, 2, 3 or 1, 3. So 3 pairs are possible for transaction T1. So we will try to find out how many times 1, 2, item 1 and 2 has been brought together throughout our data set. So we can see here 1, 2 is present here also and it is present here also. So I can say it is brought twice. Like that, item 1 and 3 has been brought only once because none of the transaction has 1 and 3 together as an item. Okay, similarly 2 and 3 has been brought only once. So like that, you will try to find out the pair of every transaction over here. In the next, let us try to find out 4, 5. 4, 5 is coming here. It is also coming here. It is coming here also, and in the transaction T6 also. So I can say my pair 4, 5 has been brought 4 times throughout the data set. Hence the value count of that particular pair is 4, 5. Like that, you can try and find out for the other pair. Okay, the third transaction is 1, 4, 5. Let me tell you, here we will take 1, 4. Okay, so 1, 4 has been brought once here and once over here. So I can say the count is 2. Then why not 4, 5? Because we have already calculated it in the previous transaction. Hence we will not write it again. Okay, and we will only write down 1 and 5 which the count is 1. Like that, I will try to find out for T4, which is 1, 2, but as it has been already been counted in T1, hence we are not writing. 2, 4, which was not counted earlier, so we have written it down here. 2, 4, okay, it has been required here and also in the transaction T6. While 1, 4 has already been taken care in T3 transaction, hence we are not including it. Like that you will finish for T5 and T6 transaction. Students, if you want, you can please pause the video, try to calculate it on your own and then cross check whether you are getting the right answer or not. Now that we have already got the count of each and every pair, again we will try to find out how many of this pair has passed our threshold exam. Okay, as we know the threshold value is 2. How many of this are pair having the threshold value more than 2? So let us see here. As we can see, the first pair is 1, 2 having a threshold value, or sorry, having a count value 2. Here having the count value 1. So if the count value is below 2, it does not pass as our threshold. So we can see only pair 1, 2, 4, 5, 1, 4 and 2, 4. This 4 pair has only satisfied our threshold. That is why further we will not be considering any other transactions other than that. So what is our candidate set now? The candidate set now is 1, 2, 4, 5, 1, 4 and 2, 4. Okay, so in the step 3 what we have done, students, we have eliminated the pair count whose value is less than the threshold. Okay, so step 3 is clear. Coming to our step 4, now that we have already found out, okay, this pair makes the transaction. Okay, now we will try to find out which buckets they are going with, okay, which bucket this particular transaction to be put. To find out the bucket number, we have to use a formula which is called as Ij mod 10. Ij stands for the items which are brought together. Let's say I am talking about the pair 1, 2. So I is 1, j is 2. So 1 into 2 mod 10. That will be my bucket count. Why it is always mod 10? In most of the sums, a normal assumptions is done that you will be having a normal mod size as 10. Okay, you may have some different mod sizes also, but most of the time in most of the sums it is mod 10. Like that we will try to make the bucket number for each and every pair or each and every candidate set that we have made. So the first one is 1, 2 mod 10. So we know the bucket size over here will be, bucket number over here will be 2. Like that I have 4, 5. So I will do 4 into 5, that is 20 mod 10, which is equal to 0. The next one is 1, 4. So that is 4 mod 10. So the number is 4. And like that for 2, 4 also you have 8 mod 10. So the value is 8. So like that you have found the candidate set and you have also found out the bucket number now. Now this was your step 4 where you have calculated the bucket number. Coming to step 5, which talks about the candidate set table. For this you have to make this table which will be consisting of these 5 columns called as bit, bucket number, count, pair and candidate set. Out of which few value you have already calculated. That is, first is the pair. We already know which pair are satisfying our condition. So first you will write down the pair. So you know it is 1, 2, 4, 5, 1, 4 and 2, 4. You also know the count of those pairs. So the next thing is you will write down the count of those pairs. So you know it is 2, 4, 2, 2 as we have already calculated it. In the step 4, you have also calculated what is the bucket number for that pair. So you have done it. You know that the bucket number for pair is 2048. So you have written it over here. Now you are left with only bit and the candidate set. Bit attribute is a binary attribute over here which will have the value 1 and 0. It will have a value 1 if a pair satisfies the condition. What was the condition? Threshold is 2. Now you may ask the question that we have already made sure the threshold was equal to 2 and that is why we have included it into the pair. So why to calculate the bit again? Please understand students, when you are trying to solve a sum, it is a static sum. Only 6 transactions are given to you and you are trying to calculate it. In real life, big data examples are streaming examples. Streaming example means the data keeps flowing. It's not a static one. So in that case, we need to cross check again at the last step, means at this step, whether the pair that we are including, it is satisfying the condition or not. Only for that case, we will be having the bit attribute. If the bit value is 1, then you will add that particular pair into the candidate set. Like that again, my next value is 4, 5. As we know, it satisfies the count. I will add the bit 1 and I will put it into the candidate set. Like that I'll do for my third pair also and for my fourth pair. So final output that I am getting is the final candidate pair over here is 1, 2, 4, 5, 1, 4 and 2, 4. So this is how you solve your PCY algorithm in this 5 steps. Normally this sum comes for 10 marks in exam. Okay, if you have any doubt you can ask me, you can comment it. One more unsolved example is given over here. We will also be solving this example in a coming video. In this we have taken 12 transactions, if you can see, from T1 to T12. But please understand, there are only 6 items, 1, 2, 3, 4, 5 and 6. So step by step try to solve this particular transaction and please let us know that which candidate set has satisfied this. Thank you so much for watching our video.